In this video, we're going to look at several trends that we find on the periodic table. Before we begin, I would like to think about the word trend, and so I brought in the definition of trend. And so trend, you can see there the first noun, a general direction in which something is developing or changing. And then the verb, the first definition is a verb, a change or develop in a general direction. So trends are patterns, and a periodic trend is a repeating pattern. And so on the periodic table, we're going to look at 3 repeating patterns. And why trends are important for us to think about, as you can see on the slide, that it allows us to predict the chemical properties of the elements. So when we can identify trends, it helps us to predict and then understand a little bit better. So we're going to look at metals, nonmetals, and metalloids, which should be a review from a previous chapter. We're going to look at the atomic radius, which is the size of the atom and its patterns, and then something called ionization energy, which I'll define when we get to that slide. So this trend of the location of metals, nonmetals, and metalloids should be a review. So make sure you know this. We will be using metals and nonmetals in particular and their location on the periodic table throughout our discussions of bonding. So just as a reminder, the periodic table can be drawn with a stair-step line here on the right side of the periodic table. And that stair-step line is the divider between metals on the left. In this illustration, they're in the green. And then nonmetals on the right. In this illustration, they're kind of the lavender purple color. There is one nonmetal that hangs out on the metal side, and that's hydrogen. Then we see in the peach color, the orangish color, along the stair-step line, many of the elements, except aluminum, identify as or are identified as a metalloid. And so those are kind of in between the metals and the nonmetals. So in this slide here, I have a summary of the different properties, and you can review that, including their how lustrous they are, which means shiny. Malleable means ability to be bent and formed into shapes, and their conductance. So those are a review from previous, but the one I want you to focus on for this chapter are these right here. So as we begin to talk about bonding in future videos, I want you to try to start getting into your mind how metals and nonmetals are in the relationship to their valence electrons. So metals tend to lose electrons to form cations, and cations are the word for a positive ion. Remember, an ion is something that has charge, and our charge can be positive or negative. Nonmetals like to gain electrons, and we'll learn why this would be, but right now we're just thinking about nonmetals wanting to gain electrons, and when you gain electrons, you form anions, and that's a negative ion. So moving forward, you do need to know the location of metals and nonmetals in relationship to the periodic table. So if you're given an element, you can identify it into one of the categories. And then when we start to talk about bonding, we're going to need to remember that metals tend to lose electrons. And when you lose electrons, cations are formed. And nonmetals tend to gain electrons, which forms negative ions. So that's one trend, the location of the metals and nonmetals. Our second trend is atomic radius. Now, what atomic radius is referring to is the size of the atom. So if you think of a circle or a sphere, the radius is the point from the center to the outside. That's the radius. So if we're talking about atomic radius, that's another way of saying the size, how big the atom is. Now you can see here I've written the general trend. It decreases up a group and decreases from left to right. So I like, when I think about my trends, I like to have them moving in the same direction. So what the trend is, if you look at this illustration, and the trend is most predominant in the main group or the representative group. So those are all the groups, the taller groups on the periodic table, or the ones that have an A in their group number. That's representative group, or also known as the main group. Transition metals also have this trend, but it is not as dominant. Some of the atoms will kind of almost be the same size as we go across. So we're really thinking about these representative elements. And if you look here at this illustration, what it's saying is that the size decreases, so it goes from larger to smaller as we go across, and then it decreases as we go up. Now you could also put these trends in the relationship of increasing, as I just did, decreasing. What it tells us is in the upper right-hand corner, these are the smallest atoms. And in the lower left-hand corner, down here, these are all the largest atoms. And in general, because of the trend, we can see that metals are going to be larger than nonmetals. So that is the second trend, the size of the atom. So let's look at the third trend and our final trend, and it's ionization energy. We have not talked about ionization energy before, and the definition of ionization energy is right here. So when you form an ion, that means that an electron can either be lost or gained. So if you think of ionization energy, we know it has something to do with developing a charge or turning into the ion. In this specific case, the ionization energy is how much energy is required, and they're removing an electron. Now, you can have multiple ionization energies, and you see here next, there's first ionization energy, second ionization energy. It could go on and on, however many electrons you have. The first ionization energy would be the energy required to remove that outermost electron. So the last one in would be the first one out, and that would be the first ionization energy. Then as you went in to the next electron, that would be the second. And you could keep going in and in. Now, as you start removing more electrons, it requires more energy because remember, the nucleus is a positive charge because it contains the protons, right? There's protons in the middle, so we have the positive in the middle in the nucleus, and then we have our little electrons out here, and I'll just draw them farther and farther. So what happens is if you remove one electron, all of these electrons get pulled in tighter. So then if my nucleus is here, then the electrons all get a little bit closer to it because the nucleus, the positive charge, is able to draw the electrons in more. If I removed another electron, it gets harder because it got pulled closer to the nucleus. But then again, the remaining electrons would get pulled even tighter. So as you remove electrons, the ion becomes smaller and smaller from what they call the parent atom, so where it started. So the first ionization energy is going to be the least, and as you try to remove more, it's going to get harder. So the ionization energy is going to get larger. Now we're just going to look at the energy to remove the first electron of the atoms, and we're going to look at it as a trend. And again, here's a diagram in the bottom of this slide, which is written a little bit differently, but let's see how we would look at it. So you can say, read the trend. It says, in general, it decreases down a group and increases left to right. Okay, I usually like the same direction, but this is okay. We'll go this. So let's look. Decreases down a group. So if we look